Okay, so we're on Unit 8B.9. Okay, Unit 8B.9. Okay, and we are going to be solving log equations today. Solve log equations. So, first thing you need to do is we need to make sure that we remember our properties. Okay, so I want you to write out your three properties, please. Okay, so you need to make sure you remember the product rule, the quotient rule, and the power rule. Yes, I make you write them every single time because a lot of people are not using them correctly, so I'm, at some point, hopefully, they're going to stick in your head. Good.
What is it?
So that means so please, share with me, what does the product rule say?
Come on, Breezy.
Hey, tell me about the product rule.
Oh, it's log base 10.
No.
No.
Log base b of n, log base b
of
m multiplied by n is equal to log base b of m plus log base b of n.
That's what I said.
I'm so proud. Okay, the next rule is the quotient rule. By the way, these most likely will not be posted for your test. So,
We need this.
well, you need to memorize them. That's why I am having you write them every single day.
Keep a song for
How
me.
many examples are there?
Product rule is live.
There are 8 examples. Okay, and then the last rule is the power rule. Okay, the power rule, is log base b of m to the p power is equal to p multiplied by log base b of n. So there are a couple of steps that we will take when we are solving log equations, and the steps are, step 1 is to condense to a single log, with same base, same base on each side. Okay, that's your first step when we're solving log equations. Step 2 is to drop common base. Drop the common base or the log base. And then step 3 is to solve for x. Okay, so these are fairly simple instructions, or steps, excuse me. We have done stuff like this already. So in solving for the expressions, okay, we've done that before, but today they're going to be kind of combined with that product, quotient, and power rule before you can solve. Okay, so your instructions are going to tell you to solve for x. Solve for x. On problems involving E. Problems involving base E. Leave answers in terms of base E. Okay, so on problems involving E, leave answers in terms of E. Do not approximate. So that means you are not going to plug in 2.78 for whenever you see E. I do not want you to approximate. Okay? You also need to know that some problems may have no solution. Some problems may have no solution.
Isn't there always one problem that doesn't have?
So, for number 1, number 1, log base 2 of 3x equals log base 2 of 96. Now, first thing you need to know is that we will always have the same bases here. Okay, so you're not going to have like log base 5 on one side and log base 4 on the other side. You will always have the same bases. Eventually, once we get to our last set of notes on Friday, that is the only time we will have different bases. And I'm going to teach you how to get it to be the same base. But first off, these are already the same base. So your first step is condense to a single log with the same base on each side. We have one log on each side, so that's fine. Then you can drop the common base or the log base. So since these are exactly the same, you can drop the log base 2's. So log base 2's basically cancel each other out. And then that leaves you 3x equals 96. How would I solve from there? Divide both sides by 3. X equals 32. That's your answer. And that's it. Okay? Should be fairly simple. Okay? This should be fairly simple. It will, yes, of course, it always gets a little bit more complicated. But that is the general idea.
Are the logs always going to be the same?
I've already been over that. 2 multiplied by log base 5 of 4. Yes, Brian, the logs will always be the same. Equals log base 5 of 2x. 2 log base 5 of 4 equals log base 5 of 2x. So this one's just a little bit different, okay? Now, when I told you to condense to a single log, I mean I need to have nothing in front of it. So how do I move that to? It's a power rule, right? So this becomes log base 5 of 4 squared equals log base 5 of 2x. Now that you have just log base 5 on each side, you can drop it. And then we set these equal to one another. What is 4 squared? 16. So 16 equals 2x. Divide both sides by 2. 8 equals x. That's your answer. Any questions so far? Not too bad? Okay, let's try another one for number 3. I would like you to again solve for x. Log base 6 of 3 to the x power equals log base 6 of 81. Log base 6 of 3 to the x power equals log base 6 of 81. So you already have the same log base, so you can drop those. There's nothing attached to the front. Then just set these equal to one another. So 3 to the x equals 81. This goes back to, I think, like the second or third notes for this unit. What do I have to do? Get the same base. So 3 to the x equals, 3 to what power equals 81? The fourth. Now you drop these bases again, so we're going to kind of double drop things here. X equals 4. That's your answer. Okay, so it is possible that sometimes you will have to drop both, or drop bases multiple times. Excuse me. For number 4, example 4, how about log base 2 of 3x plus 7 equals log base 2 of 4x minus 8. We've already been over that.
You did?
Yeah.
So
Log base 2 of 3x plus 7 equals log base 2 of 4x minus 8.
I think I was listening.
Drop the log bases and set what was in the parentheses equal to one another. So 3x plus 7 equals 4x minus 8. So we're going back to old school algebra 1 stuff. Move your numbers to one side, move the letters to the other side. I'm going to move the 3x to this side. So if you subtract the 3x, we get just x. You add 8 to both sides, you got 15 equals x. Questions so far? Okay, so up until now, I think this was fairly simple, right?
Yeah.
Okay, we're going to make it just a little bit more complicated in this next one. Okay, for number 5. Let's try log base 4 of x minus 2 equals log base 4 of 25 minus log base 4 of 5. Log base 4 of x minus 2 equals log base 4 of 25 minus log base 4 of 5. Now we actually need to do that first step. So the first step was condensed to a single log. So this one's fine. How can I condense this to be a single log? Make a division, right? Use the quotient rule. So log base 4 of x minus 2 equals log base 4 of 25 over 5. Okay, now that you have log base 4 on both sides, you can drop those logs. So x minus 2 equals 25 divided by 5 is 5. Add 2 to both sides, x equals 7. Okay, let's try another one, number 6. Let's try natural log, so ln natural log 2x plus 3 minus natural log x minus 2 equals natural log of 4. Natural log 2x plus 3 minus natural log x minus 2 equals natural log 4. Okay, does anything change because we have natural log in front? No. What is another way to write natural log? Log base e. Okay, these are all the same. You do not need to rewrite these as log base e. Okay, but I do need to condense this to be a single log. So how can I do that? Division, right? So natural log 2x plus 3 over x minus 2 equals natural log of 4. Now I have the same log base on both sides, so both natural log, I can drop those and set these equal. 2x plus 3 over x minus 2 equals 4. Now, from here, this is something that I absolutely promise you learned in pre-algebra or algebra 1, but people forget how to do this. How do I solve?
Oh, I know how to do this.
Cross multiply. Remember, 4 is really like 4 over 1. So you cross multiply. So multiply across here, multiply across here. Right? You can draw the little butterfly wings or whatever you need to if you need to. So we're going to do 4 times x minus 2 equals 1 times 2x plus 3. So you just distribute. So 4x minus 8 equals 2x plus 3, and then solve, just like we used to in Algebra 1. So move the 2x to the other side, that gives you 2x equals, if you add 8 to both sides, gives you 11. Divide both sides by 2, x equals 11 over 2. As long as it is reduced, you can leave this as an improper fraction. Okay? It is fine to leave it as an improper fraction as long as it is reduced. Okay, just a couple more. Number 7, I want you to solve log 3 to the 2x power equals log 27. Log 3 to the 2x power equals log 27. What is the base on both sides here? 10. Base 10. So since I only have one thing on each side, I can drop the log base 10s. Then set these equal to one another. So 3 to the 2x equals 27. From here, this is just like what we did a couple objectives ago, a couple sets of notes ago. How do I do that?
3 to the base.
I'm going to rewrite it to the same base. So 3 to the 2x equals 3 to what power equals 27? 3 cubed. Then drop your bases again. 2x equals 3. Divide both sides by 2. X equals 3 over 2. We also did some of this stuff in 8a, but it just didn't have the logs. That's why 8a used to be with 8b, because exponents and logs are actually the same thing.
It's basically
I'm sorry?
basically this, but without logs.
Right. Yeah, so we didn't have to deal with logs in 8. Okay. Great, last one. I want you to try log base 7 of x equals 2/3 log base 7 of 27 minus log base 7 of 5. Log base 7x equals 2/3 log base 7 of 27 minus log base 7 of 5. Okay, so the left side is fine. It has 1 log on it. How do I condense this right side?
Power.
Okay, it's going to be division, but what do you have to do before you can do the division? The power, right. So move this to be a power on 27. So log base 7 of x equals, this is going to be log base 7 of 27 to the 2/3 power. It is okay to also do the division at the same time. Okay, that is fine. Now, how can I rewrite 27 to the 2/3 power? Power handle, right. So change that to be log base 7 of, that's 27 to the 2nd power cube root, still over 5. What is 27, the cube root of 27?
3.
Right. So if I get log base 7 of, that is 3 squared over 5. What happens here is you can drop the log base 7s, and that'll give you x equals, what's 3 squared? 9 over 5. That's your answer. Any questions on how I did that? Okay, the assignment for this is going to be worksheet 9. You're doing numbers 1 through 15. Okay, it's only 15 problems. You do need to write down the problems, and please, please, please show some work. Okay, please.